All right. Good morning, good evening, good afternoon, whatever time it is that you're watching this. Hopefully that your week has been going well thus far. We are home stretch. We only have one more lesson of Unit 3, and then we are done altogether. All right. So I appreciate all of us who have um, put our best effort forward in terms of just looking at these videos that I've made in my absence. But we're getting close to the end. And on top of that, we're getting close to Thanksgiving break, so we can enjoy ourselves and get away from school for a little bit. Before we start today's lesson, I do want to share my screen because I do have a couple of announcements for us. So just give me 1 minute as I get that set up, and then I will share that with you. Okay. So, in terms of our announcements today, the first thing, just please make sure that you check your grade on Blackboard. I've been doing a lot of grading this past week to kind of get us caught up so that way you have a better idea of what your grade is for the class. So, everything that you see on Blackboard right now, as of November 18th, is up to date. Okay, so everything you'll see there from exit tickets to lesson completions of your packet, all those grades have been updated and put into Blackboard. So make sure you check that. Um, the speaking of exit tickets, the last exit ticket that we took, which was from last week, lesson six, that was actually due on Sunday. I know some of you all reached out to me because maybe you didn't realize that the exit ticket was given out, or quite frankly, you might have just forgotten that it was on Illuminate. So what I did was I went ahead and I extended the due date for that exit ticket to this Friday at 11:59 p.m. So if you want to take that exit ticket, or if you need to finish that up, please make sure you do so before Friday night. And the access code for that exit ticket is on the screen for you as well. So you can just copy and paste that. Also, there will be an exit ticket for today's lesson, the final lesson for Unit 3. All right. And similar to that Lesson 6 exit ticket, this one will also be due on Friday by midnight. So please make sure that you take time in class today or in class Friday if you have class on Friday. I'm not sure what's going to be going on, but either way, just please make sure you finish these two exit tickets before then. The last announcement I have is that the Unit 3 exam, because we're getting done with the lesson or the unit, so we're gonna talk about the summative. The Unit 3 exam for us will either take place on December 8th for my A day classes or December 9th for my B day classes. So please make sure you have those two dates circled on your calendars. And even better news for that, well, I'll give you more details. The good news is that I will be returning to school for those assessments. So, good news is that when you guys are taking your summative, I'll be available to, assist you all in helping you out before we get into midterms and before we go off for winter break later down the road. All right, so those are the announcements that I at least had that I wanted to share with us first before we get into this final lesson. All right, so now we're going to go ahead and move forward with that. So we're going to move to page 31 of our Unit 5 packet, and that is where we're going to find our do now for today. All right, so for this do now, as you can see, there are five problems listed here. All right, and the goal for this do now, all we're just trying to do is that we're trying to look at each of these problems here provided, and we want to write the inverse of each of these functions. So if you need to recall the notes on how we write inverses of these functions, I would suggest going back to your notes on page 29, as that will help you in terms of using those steps that I had created from the previous lesson and writing out these inverses. So I'm just going to leave a note for you here to go to page 29 for assistance. Okay, so I want you to take 5 minutes on your own, see if you can answer as many, if not all, of these questions here. And then when you unpause this video in a moment, We're going to look at the answers for each of these so that way you have them and seeing if you're on the right track or not. So at this point, go ahead and pause your video, and then when we come back, you will see the answers. Okay, so we are here, and these are the answers for the inverses of each of these functions. So for the first one, you should have had log base 4 of x minus 4. For the second one, you should have had log base 6 of 2x. For number 3, you should have had 10 to the power of x divided by 5 minus 2. Remember here that for this, if there's no base for your logarithm, assume that it is the number 10. Hence why we have our base here of 10. For number 4, what you should have had is 3 to the power of x minus 7, and you're dividing all of that by 3. And then for number 5, I'm going to scroll down just for a little bit. What you should have had is e to the power of 4x. Remember, your base is e here because we're dealing with the natural log, and that's what the base is for the natural log. So you have e to the 4x minus 2, because of this plus 2, move to the outside. And because we're multiplying by 7 also on the inside, that is why our inverse, we are dividing by 7, all of that on the outside. All right, so this is our answers, or these are our answers for our do now questions. So if you're still stuck on writing out inverses for functions like these, please make sure you ask and please make sure you work together or reach out to me directly because you're going to have to deal with these types of problems on your summative when we come back from Thanksgiving break in a couple of weeks. So please make sure you are familiar and comfortable with doing this process. And if not, please make sure you reach out to me directly. All right, so in our final lesson for today, as you can see at the top, lesson 8, we are going to be looking at solving exponential equations. So as we move to page 32, you're going to see an example, or we're going to do a practice problem together, where ideally we're going to figure that out. We're going to try to figure out or do problems similar to what you see at the top of the page. So for this, on page 32, we're considering the following equation. We have 2 to the power of 3x, and this equals 20. Okay, and the goal is to find the value for x to make this equation true. So we're just basically solving for x here. Now, when we are dealing with solving exponential equations, there are a couple of steps that we're going to do, and we're going to outline them in our notes here on this page. So the first step that we're going to do in order to solve this equation is that we're going to take the log of both sides. So how that looks is that we're going to say the log of 2 to the power of 3z. Oh, I guess this is a typo. My apologies. I just noticed this. Change that to an x. That'll probably make it a little bit easier for us. So it should just be log of 2 to the power of 3x is equal to the log of 20. So again, that's just the first step. We're just taking our equation from up top, and we're just taking the log of both sides. Now, at this point, we're dealing with logarithms, so we want to recap some things that we learned in regards to logarithms, some things that we can and can't do. And this goes back to lesson 6 from last week. So you might remember, first things first, couple of the properties. If you're multiplying two things inside of a logarithm, if you remember what we did there, what you can do is, remember, you can split it up into two parts and add them together. All right, so that was our rule. And I'm going to zoom in a little bit just so you can see this. So that was our first rule when it came to logarithms. If you're multiplying two things inside of it, you can split it up into two parts, and then you just add the parts together. Likewise, if we're dividing two things inside of a logarithm, same idea, we said, okay, split it up into two parts, But this time, instead of adding them together, what we're going to do is subtract them. And right, in our final property when it came to logarithms, we said from before, if you had an exponent um, inside of a logarithm, what we said from before is that we said take that exponent and move it to the front. All right, so all of these properties are still going to be coming in play when it comes to solving exponential equations. All right, so you have to still be familiar and comfortable with logarithms because we're doing opposites, we're taking inverses just so we can try to get x or our variable by itself. All right, so now that we recall these properties, all right, now we're going to put them into action, looking at the example problem that we had from up top. So I'm just going to rewrite it again here at the bottom, all right, because the goal now for the last part is that we're trying to get our variable by itself. So we were at the point where we had the log of 2 to the power of 3x is equal to the log of 20. All right, so now note here we have an exponent of 3x. So like we said just at the top here, take your exponent, move it to the front of our logarithm. So that is what we're going to do. So instead, what we have is that we have 3x, because that is our exponent, times the log of 2 is equal to the log of 20. So now the goal here is still to get x or our variable by ourselves. So I want to get x by itself. So that means that I need to get rid of this 3 and I need to get rid of this log of 2. Okay? Both of those are being multiplied by x here. So do the opposite. So what we're going to do is that we're going to divide both sides. We're going to divide both sides by 3 and we're going to divide both sides by the log of 2. Because if we divide both sides by those two things, those cancel out, and I just have x by itself. But of course, what we do to one side, we have to do to the other. So that means that I have to divide this side by 3 and by the log of 2 as well. All right, so my final answer, if I want to find what x is, what I need to do is that I need to do the log of 20, and we're dividing that by 3 times the log of 2. All right, now in this case here, I'm gonna open up a calculator for us, or at least for myself, so that that way I can get this. So give me 1 second. And then I'm gonna go ahead and share this with you as well. All right, you might not be able to see that, so let me go ahead and zoom in for us. All right, so we had here, we need to do is that we need to do the log of 20, and we're dividing this by, so I'm going to put this all in parentheses in my calculator just so it tells us that this is all going to be on the bottom. So I'm going to do 3 times log of 2. I'm going to close that out. And if I hit enter at this point, it tells us that our final answer is going to be 1.44. All right, so if I go back to my page here, my final answer for x would be 1.44. And I'm done. So In terms of solving these exponential equations, it's hopefully not hard. It might be tedious, but the key here is just making sure that we take the log of both sides to start. Then we just need to recall our properties of logarithms, which we wrote out, and then using those properties to try to get our variable, which in this case is x, by itself. And that's how we get to our final answer. All right, so we have one final page of our notes, and the final page is page 33. All right, so on page 33, if you move to that page, you will see that five there are five practice problems that are here. All right, we're not going to go over every single practice problem, but there are a couple that I do want to highlight. All right, so we're going to look at doing numbers 3 and number 5. All right, so we're going to start here with this one. All right, so for this problem, you have 10 to the power of 2x plus 7, and that is equal to 1. And again, the goal is that we are trying to get x by itself and figure out what is that going to be equal to. Okay, so first step is that we want to go ahead and take the log of both sides. So I'm going to do log of 10 to the power of 2x plus 7, and this equals the log of 1. So now at this point, we have done what we had to do. All right. So now what we just need to do is just recall our rules for logarithms. It says here that if you have an exponent, which is all of this, so that is our exponent, take it and move it to the front. So if we were to do that, we would have 2x plus 7, because that is our exponent, times the log of 10 is equal to the log of 1. Now, at this point here, I just want to take time just to pause for 1 second. All right. Because it might actually be easier just to actually figure out what these numbers are equal to before we move forward. All right. So, first off, the log of 10. If we were just to put that into our calculator, all right. So, if we were just to do that, we would actually find out that the log of 10 is just happen to be equal to 1. If I did that for the log of 1, which was on the right side, if we did the log of 1, we would find that that is equal to 0. So in this case here, going back to our problem, we know that the log of 10 is equal to 1, and we know that the log of 1 is equal to 0. So why not we just take this information and substitute it here? So really what we have is that we have 2x plus 7 times 1, because that's what the log of 10 is, and that equals 0. So really what you're dealing with here is a basic algebra 1 problem where you have 2x plus 7 is equal to 0 and solve for x. So we have done these problems multiple times, numerous times in the past. Subtract 7 from both sides. Then we get 2x is equal to -7. Then go ahead and divide both sides by 2. So if we did that, we would get x is equal to -7 over 2, or if you want to write that as -3.5, either or is the correct answer. All right, so while we use the same steps from before, like in our notes on the previous page, we just had to look for a couple things just to make it easier for us in terms of getting to the final answer. We notice here that the log of 10, hey, that's a special case. That's just equal to 1. And the log of 1, that's also a special case. That is just equal to 0. So why not we just use that to make our lives a little bit easier to solve for x by itself? So that's really the only thing that we had to adjust in terms of just getting to our final answer here in this case. Okay. Now, I did say that I was only going to go over problems 3 and 5, but I just want to highlight something for number 4 right quick. I'm not going to do the whole problem. I'm just going to help us set it up. All right. So in this case here, we have e to the power of 2x minus 10 is equal to 0. All right. Now, if we just tried to use the steps as we did before, if we tried to take the log of both sides right now, we're going to come across a few issues. All right. The first issue, there's no rule in terms of what happens if we're adding or subtracting inside of a logarithm. So unfortunately, we can't do anything with this. This is as simplified as it could get. We can't do anything beyond that. And on top of that, this log of 0, if I were to take my calculator and actually type that in, remember that if you do the log of 0, what's going to happen is that you're going to come across a domain error. All right. And that makes us even more stuck. Okay, so it's like, well, where in the world do we go from here? So in this case, first, before we even start taking the log of both sides, it's going to be important to kind of do a little bit of rearranging for this problem first, so that way you can then go ahead and take the log afterwards. So before I even do this step, the first thing I'm going to do here is that I'm going to actually go ahead and add 10 to both sides. Because if I do that, okay, then what I'm left with for number 4 is e to the power of 2x is equal to 10. All right, now with this setup, I can go ahead and use the first step, take the log of both sides, and then go from there. All right, so I just wanted to at least highlight this problem here first, so that way you're not going down the wrong road in terms of getting to this point and you're getting stuck and getting domain errors. So just make sure you rearrange your problem first, so that way when you take the log of both sides, you don't come across that issue. Okay, so that's just number 4. You still have to finish it, but at least I gave you a head start on it. But I'm going to move to number 5. All right, so number 5, we're going to do this problem together. It says that our friend Jermaine is investing in Bitcoin. He's trying to find how long it would take for $6,000 to triple when invested at an annual interest rate of 10%, compounded continuously. Ooh, okay, we have not talked about this for a while. The key phrase here is compounded continuously. We've talked about these types of problems way back in lesson 2. So that was like, what, 2 or 3 weeks ago. All right. And we're going to be implementing it here as well. So when you have a compound continuous interest problem, we have a specific formula for that. And that formula, if you remember, is APERT. A equals P E to the power of R times T. Now, hopefully this formula kind of looks familiar to you, but okay, remember I'm just labeling it so that you remember what each of these parts is equal to. Remember, A here represents your final amount. Remember, for this equation, P is your initial amount. Okay, remember R is your rate and T is your time. And lastly, I didn't label it here, but remember E is Euler's number. It's just a number. All right. So we don't really have to care about that or concern ourselves with it. All right. So now that we have this label, let's go back to the context of our problem. All right. It says that Jermaine is starting with $6,000. So in this case, $6,000 is our initial amount. Now, the goal for Jermaine here is that he is trying to triple this. So if we think about it, our final amount, if we're trying to triple $6,000, all right, tripling means multiplying by 3. So that means that our final amount, the goal is that we're trying to get to $18,000 because that's what 6,000 times 3 is. Okay. And I'll write this on the side. We get this from doing 6,000 times 3 because we're trying to triple that. Now, we also know our rate here is 10%, but remember percentages we have to write as a decimal. So that means that our rate here, instead of 10, we're going to write this as 0.1 because that is what 10% is equal to. And then lastly, we just need to find time because we don't know that. So now, if we rewrite this problem using this context here that we have outlined, what we have is that we have 18,000 is equal to 6,000 E, and then we have zero point 0.1 times T. All right, so if you look at this setup here that I've rewritten based on the information provided, this here looks very similar to these problems that we have been doing at the top of page 33 or on the guided practice on the previous page. So it looks almost similar. The only thing that we probably would want to do first before we even start using the steps from before is that I want to make this a little bit easier for us. So maybe we want to get rid of this 6,000 first. All right, so this 6,000 is being multiplied. So why not do the opposite? Let's just divide both sides by 6,000. So if we do this, those two cancel out. And on this side, if I have 18,000 divided by 6,000, that is just equal to 3. So really, this whole problem boils down to 3 equals e to the power of zero point 0.1 times t. So now looking at this setup here that we have, all right, now this actually makes it a little bit easier for us. Okay, so now let's just go ahead and do the steps from before. Go ahead and take the log of both sides. Log of 3 is equal to the log of e, to the power of 0 point 0.1 times t. Okay, then take your exponent, which we have here, move it to the front. So we have the log of 3 is equal to 0 point 0.1 times t times the log of e. All right, and so from here, if I want to get our variable, which in this case is t by itself, I need to get rid of this 0 point 0.1 and I need to get rid of this log of e. So what this means is that if we want to find our value for t, we need to do the log of 3, this here, divided by 0 point 0.1. So get rid of this, the opposite is division. Get rid of this, the opposite is division. So we're going to divide all of this by 0 point 0.1 times the log of e. All right, so if I plug this into my calculator, let's see, we have, let's get rid of this right quick, let's clear out. So we have the log of 3 divided by 0 point 0.1 times the log of e. Now, for this, excuse me one moment as I do this. For you all to, if you're just writing the log of e, how we're going to do that is that we're going to hit second, then we're going to hit the ln button. All right, note here, it's asking you to put a number here for your exponent. All right, so in this case, you're just going to put 1 because e without an exponent is just the same as e to the power of 1. So in this case, just put a 1 there and that'll help you out. All right, then we're going to close this out. And then if we hit enter, we get 10.99. All right, so that means that our value for t is 10.99. And then we are done. We're going to put in 9, make this 9 look a little bit better. All right, so this problem is unique because it's taking what we have learned previously with compound continuous interest problems and using this formula from before and actually showing you, oh, I can actually solve for time now using these steps that we looked at from our notes and actually getting a value here. So that's how we do it. All right, so the rest of the practice problems that you have left, you have number one, you have number two, and you still have to finish up number four because we didn't finish that. All right, so you need to make sure that these three practice problems are done after Thanksgiving break when we return. All right, and then as I mentioned before, the final piece of Unit 3 that you need to make sure that you finish is the exit ticket for this lesson. All right, so let me share. I'm going to go back to sharing my screen right quick. So for your exit ticket for lesson 8, you just have to, as before, go through either the Illuminate Student Portal app, where it'll be there for you automatically, or if you need a code to access the exit ticket, the access code is provided for you on the screen here as well. This UYHMCWV. That is how you gain access to your exit ticket for lesson 8. All right. This exit ticket only has 5 questions where it kind of takes some things that we learned from lesson 7 and from this lesson here, and it's kind of mixing them together. All right, so you're going to see a little bit of both. All right, now, as I said at the beginning of this lesson or at the beginning of this video, this exit ticket is due on Friday, the 21st by midnight or 11:59 p.m. So if you do not finish it in class, please make sure that you take time throughout the rest of this week to get that knocked out because you don't want to have to worry about it or see it marked as missing before you go on Thanksgiving break. All right. So once you have all of those pieces completed, and once you have all those pieces done and filled out on your end, then that means that you, my friends, are done with Unit 3 altogether. So kudos to you. Kudos to you all for finishing that up. And kudos to you all for managing to get through Unit 3 in my absence as I've been on paternity leave. All right. Now, don't forget that the Unit 3 summative is on December 8th, and that is when I return. So you will have me there to help you out with answering questions on exam day if need be. And then when we come back from Thanksgiving break, we will make sure that we give you guys a like a study guide or like a practice test to help you with preparing for the summative in a couple of weeks. All right. But if you don't have any other questions, you guys have your assignment. You guys know the expectations. So please make sure you get that knocked out. Otherwise, if you get this all completed, please make sure you guys enjoy your Thanksgiving break. Get this time off to relax, get away from school, kind of get yourselves like refreshed before we go into that last, couple weeks of school before, midterms, and then we're finishing up semester one altogether. Hallelujah. All right. So enjoy the rest of your days, enjoy the rest of your weeks, enjoy your break, and I will talk to you guys when we come back from Thanksgiving.